Today, we're going to trace the incredible, high-speed journey a computer takes from being, just a cold, dark box to a machine that's fully awake and ready to go. Okay, let's dive right in. We've all pressed that power button a million times, right? But the real magic, the truly fascinating stuff, happens in those few moments just before anything even flickers on the screen. It's like an electrical ballet, and it's all performed in microseconds. So we're going to break this whole journey down into 6 key stages. We'll start with that very first jolt of electricity and follow it all the way through to the moment the main processor wakes up and executes its very first command. And it's so important to get this. This isn't some random process at all. It is a precisely choreographed sequence. Every single component has to play its part in the perfect order. Seriously, think of it less like flipping a light switch and more like launching a rocket. Everything has to be perfect. All right, let's get into stage 1, the spark of life. This is ground zero. It's where it all starts, with the very first electrons entering the system. The moment you plug in that adapter or connect a battery, power doesn't just flood the whole system. Nope. First, it's very carefully routed through a bunch of protection circuits. This whole process establishes a stable primary electrical highway for the entire system, making sure every component gets a clean and totally safe source of power. Okay, so now that we have a primary power source, the system can awaken its most basic, essential functions. I like to think of it as turning on the emergency lights in a massive sleeping city. And this is all made possible by something called always-on voltage. It's this tiny, persistent trickle of electricity that keeps the system's most basic functions, its brainstem, if you will, alive and well. This is how your computer keeps track of the time and date, and it's how it knows to listen for you to press that power button. This really shows you just how meticulous the system is. Before anything else significant happens, it sends a quick reset pulse to its internal timekeeper, the real-time clock. It's kind of like synchronizing every single clock in the city to make sure everything happens exactly when it's supposed to. It's all about preventing any timing errors later on. So now the system is just sitting there in a low-power standby state, patiently waiting for one single thing, your command. When you press that power button, you're not actually directly turning the computer on. What you're really doing is sending what electronics engineers call an ignition signal. You're basically telling the machine, hey, it's time to wake up. So think of this system conductor as the city's main power grid operator. It gets your wake-up order, and then it begins this complex process of orchestrating the grand awakening of all the other districts, bringing the whole city to life, piece by piece. Now, this is where it gets really interesting. The system conductor starts the most complex part of the journey, a cascade of power activations, where each one has to wait for an all clear from the one before it. The real symphony begins now. And here you can see that chain reaction in action. First, the conductor sends the wake-up command, and that activates the low-power suspend circuits. Once those circuits report back that they're stable, they send the first all-clear signal. And only then does the conductor activate the main power for the really hungry components, like the processor. Once that's stable, a final all-clear is sent, which confirms the entire system has good, stable power. This built-in safety check is what prevents catastrophic failures when you boot up. It's basically a series of digital handshakes happening in microseconds, making absolutely sure no component is ever powered on before its foundation is secure. Okay, with all the power rails stable and confirmed, that final all-clear signal triggers the last step before waking up the processor, a system-wide reset. It's time for a totally clean slate. First up, a reset pulse gets sent to the main communications hub that controls all your ports and peripherals. This just clears its memory and gets it ready for new commands. And that reset pulse immediately triggers another one, but this time it's for the memory hub, the gateway to the system's RAM. This tells the memory controller to clear out its registers and get ready for the processor's commands. And finally, that reset signal reaches its ultimate destination, the processor itself. This final pulse is a CPU reset that wipes its internal memory totally clean, placing it in a pristine, ready-to-execute state. The brain of our city is now officially awake and awaiting its orders. So the city is awake, all the lights are on, the control tower is reset. Now what? The processor needs its very first command. Where in the world does it look? What happens next is just so cool. The processor is hardwired by its very design to look at one single, specific memory address the very instant it comes out of reset. It doesn't guess, it doesn't search, it knows exactly where its first instruction is waiting for it. This address is literally the start of the map. It holds a single instruction, a command that points the newly awakened processor right to the beginning of the system's firmware. And that firmware then takes over and loads everything you recognize as your operating system. So, the power-on journey is complete, and a whole new one has just begun. So, if we look back, we can see this incredible journey, right? From a simple plug-in all the way to the processor fetching its very first instruction. It's a high-speed, perfectly timed sequence of events, and it all happens in the blink of an eye, every single time you turn on your machine. And that kind of leaves us with a final thought. We've seen how the engine starts, but how does that first little sputter turn into a cross-country road trip? That one single instruction kicks off another, even more complex journey, the boot process itself. Thanks for watching.